So hello everyone, welcome back. Today in this video, we'll be dealing with the chapter 3 of class 11 geography NCERT, that is interior of earth. This chapter will be dealt in two parts. This is the part first of interior of earth. So before starting the chapter, let's just think that we all have experienced earthquake in our life, maybe once, but we all have. And we have often seen mountains, plains, desert, but how are they formed? So the answer to these questions are hidden beneath the Earth's surface. And in this chapter, we'll understand why studying the Earth's interior is so important and how the forces acting inside and outside the Earth continuously shape the world we live in. So let's begin with basic introduction. Before we study the Earth's interior, let's first understand why this topic is important. So, the configuration or the surface of the Earth and the features of the Earth's surface is largely the result of processes operating inside the interior of Earth. So, in simple words, the landform we see today, the mountains, the deserts are not only formed by chance, they are outcome of various geological processes that are occurring both inside and outside the Earth. So let's think, for example, Himalayas. So Himalayas were formed due to movement taking place deep inside the Earth. We all know that when the Indian plate was moving towards the Eurasian plate, then due to folding, the Himalayas were formed. This shows that what happened beneath the Earth's surface has a direct impact on what we see today, because only due to the Earth's interior, the Indian plate started to move. And that is why we have Himalayas today. But at the same time, the landscape is continuously shaped by two processes, that is exogenic and endogenic. Now let's understand that what do these processes mean. So when we talk about the exogenic process, these are the processes which originate or which act on the Earth's surface. And when we are discussing about the endogenic process, these originate inside the Earth. So let's consider that this is Earth. If any process is happening inside the Earth, it is called endogenic. And it's easy to remember as exo means outside. Anything which is happening on the Earth, it is called exogenic. Now when we talk about the endogenic processes, like they include phenomena like earthquakes and volcanic eruption which help in creating and modifying the landforms. While the exogenic processes include the agents like river, winds, glacier and sea waves. So for example, what we see is that Aravalli mountain has reduced the size over the period of time. This is because various agents have worked upon it and erosion process has taken place. So that is how the exogenic and endogenic process both have an impact on the landscape that are forming on the Earth's surface. So the Earth's landscape is constantly changing because both internal and external forces are working together. There is not one factor working in silos of another, but both are working together. Now let's see the impact on the human life. So human life is largely influenced by the physiography of the region or the physical features which are present in the region. So let's consider an example that in fertile plains like UP, Punjab, Bihar, agriculture has more importance. While mountainous regions also have an influence on how the transportation or the settlement or the occupation of that area will be. And also the agriculture type is also different as per the areas. For example, more terrace farming is present on the mountainous regions. So this is how the physiography of a region influences the human life. And that is why it is important to understand the landscape development of any region. If we know about the landscape and physiography, we will be easily able to identify that what human life is possible here. And finally, if we want to understand that why earthquakes occur or how tsunami are generated, it is necessary to know that what is inside the interior of earth, because these endogenic processes are only the base and are considered the base and the main reason for these all processes to take place. Now let's consider the sources of studying the interior of earth. Before jumping on to the sources, let's see an animated video to understand the sources. Now, as we have seen in the video, that there can be various sources of understanding the Earth's interior. Now, there can be direct sources and there can be indirect sources. Let's study about it. The Earth's radius is about 6,378 km. No one can reach the center of the earth and make observation or collect samples of the material. Why? It is because the temperature, the density, the pressure inside the earth increases. And leave about humans, the machines even cannot reach the interior of earth. The deepest point we are able to reach is only 12 kilometers. So think, out of 6,378 kilometers, we have only reached till 12 kilometers. So how will exactly we understand about the interior of Earth? So that is why most of our information about the interior of Earth is largely based on estimate and inferences. It is just our assumption. Yet a part of information is obtained through direct observation and analysis of various material. We have two types of sources present here, that is direct source and indirect source. When we are talking about direct sources, there can be two direct sources, that is direct mining and volcanic eruption. First, let's study about direct mining. So, the most easily available solid earth material is the surface rock or the rock we get from the mining areas. When we dig deep inside the earth's surface, we get certain type of rocks. So, from that studying the rocks, we can identify certain type of characteristic or feature about the interior of earth. That is the first direct source that we can do, that is take the surface rock. So the gold mines in South Africa are as deep as 3 to 4 kilometers. Going beyond this depth is not possible as it is very hot at this depth. Beside mining, scientists have also taken up a number of projects to penetrate deeper depth to explore the conditions in crustal portions. So what we have seen here in this point is that the gold mines in South Africa are deep to a certain extent, that is 3 to 4 kilometers only. Think, out of 6,000 kilometers, only 3 to 4 kilometers. What will we even understand? But why is it so? Because we cannot go deep inside. It is so hot that even machines cannot go deep inside because they melt due to such temperature and such heat. So scientists the world are working over two major projects, that is deep ocean drilling project and integrated ocean drilling project. It is basically to drill inside the ocean, and there is a deepest drill in Kola in the Arctic Ocean, and it is only deep as 12 kilometers. Again think, out of 6,000 kilometers, 12 kilometers, what change will it make? But these drilling projects have provided large number of information. through the analysis of materials which are collected at different depths. So though we are able to reach only 12 kilometers, but even at this little depth, the kind of materials that are collected have helped us to gain some information about the interior of Earth. Now, we understood that first direct source is mining. This is Earth. If we mine and take some amount of this rock, we'll able to get certain type of surface rocks, and we can find some information from there. Now, let's talk about second, that is volcanic eruption. Now, let's first understand a simple thing, that this is Earth, and from this Earth there is this vent or there is this cone that is called volcano. From this volcano, material comes from inside the surface of Earth in the form of magma and lava, dust particles, gases, nitrogen, carbon dioxide. All of this material comes from inside the Earth. But one point that we have to understand is that only it is limited to the maximum extent of 400 kilometer. Again, think, though it can be more beneficial than the deep mining, but still out of 6,400 kilometers do not make a mark. So when we are talking about volcanic eruption, so this is another source of obtaining direct information, as in when the molten material, that is magma, is thrown onto the surface of Earth, it becomes available for laboratory analysis. And however, it is difficult to ascertain the depth of the source of magma. We do not know that this magma that is coming out of like 10 kilometers depth, 12 kilometers depth, or 400 kilometer depth, or 300 kilometer depth. We are not aware of it. So thus it becomes difficult to understand the layer by layer differentiation inside the Earth's interior. That's it for the direct sources. We do not have much of direct sources, as we've already understood that temperature, density, pressure is so much that it is difficult to collect any direct source of studying the interior. However, we have two sources, that is volcanic eruption and mining. Now let's understand the indirect sources of studying the Earth's interior. There are like 5 indirect sources, starting with the first, that is temperature, pressure and density. So analysis of the properties of matter indirectly provide information about the interior. We know through the mining activity that temperature and pressure increase with the increasing distance from the surface towards the interior of deeper depth. What is it suggesting? That okay, we know that when we move down, we know that density increases, pressure increases, and also temperature increases. We have already seen in the previous chapter about the evolution of lithosphere that the densest material are towards the core. So that is what we already know. So moreover, it is also to be known that density of the material increases with depth. It is possible to find the rate of change of these circumstances. Knowing the total thickness of Earth, scientists have estimated the values of temperature, pressure and density of material at different depths. So now we know that what is the radius of Earth. It is around 6,000 kilometers. Now if we know that what is, like for example, here there is a different temperature, here there is different temperature, here it becomes a different temperature. So by understanding the rate of change in the temperature or pressure or density, the scientists are already aware the radius of the Earth. So they can make certain type of calculations and make certain type of assumptions about the interior of Earth. So this is the only important point that you have to note from the first point, that is temperature, pressure and density, that it increases with depth, and the rate of its change can be a main key to understanding some of the features of the interior of Earth. Second one is meteor. As in the previous chapter, we have already seen the nebular hypothesis theory. We are well aware that Earth or meteor, all of these are formed from the same nebula. So if, for example, any nebular part in the form of meteor falls on Earth, then what we can study is we can study the remnant core of that meteor, and we can make an analogy that okay, that if this the core of this meteor is like this, the Earth can also have similar core because they are formed from the same nebula. So that is how we can like understand certain type of information from this meteor. So it may be noted that the material that becomes available for analysis from meteor is not from the interior of Earth. So understand that it is not coming from the interior of Earth. Temperature, pressure and density is the interior of Earth, but it is not the interior of Earth. The material and the structure observed in the meteor are similar to that of Earth. They are solid bodies developed out of the material same as and similar to our planet. Hence, this becomes yet another source of information about the interior of Earth, and it becomes easy to understand the interior of Earth. The third point becomes gravitational anomaly. What is anomaly? Anomaly is a situation where you expect something else to happen and something else is happening. So that case is called anomaly. So the gravitational force is also not same at all the latitudes of surface. Like if you're standing on poles and if you're standing on equator, the gravitation pull that will be acting on you will not be the same. The gravitation pull is more towards the pole and it is less at the equator. Why is it so? Because when we consider that okay, we have Earth is like this shaped. It is like this shaped. It has a little bulge at its pole. Now when we see that okay, this is the center, at center it will have the maximum gravitational pull. This distance is less and this distance is more. Thus the equator, at equator you feel less gravitational pull and at poles you feel more gravitational pull. So the gravitation value also differs according to the mass of the material. If I have more mass, then my gravitational pull will be more. The gravitational pull that will be acting upon me will be more. The uneven distribution of mass of the material within the Earth's influence this value. So for example, Earth, this is denser part, this is less denser part, this has more matter, this has less matter. So all of that, the gravitation pull that will be acting will also be different. So the reading of gravity at different places is influenced by many factors. The reading differ from the expected value and such a difference is called gravitational anomaly. If all of the areas had same like structure, so the gravitation also acting upon them should be same, but it is not the case. That is what it is called anomaly. So it gives us information about the distribution of mass of the material in the crust of the Earth. The next important indirect source that we have to study is magnetic survey. So magnetic survey also provide information about distribution of magnetic material in crustal portion and thus provide information about distribution of material in this part. So because Earth has its own magnetic field, we are aware that okay, there will be iron in its core, right? And we can also identify certain type of magnetic material which will be present. This is also an indication towards okay, what can be inside the Earth. Like we can make an assumption that okay, iron will be present and it will be rotating. Now solids do not rotate themselves, so thus it will be liquid which will be rotating. That is a certain type of hint. We will understand this further, but for this now, this is only the part that we have to understand. And the fifth point is seismic waves. We will be dealing seismic waves in quite detail in the upcoming slides. So the next topic that we have to start is basically earthquake. Before studying earthquake, let's see a video. As we have seen in the video, the earthquake is nothing but it's just the shaking of Earth. We have always seen that fans are moving or some building is shaking or some poles are moving during earthquake. We have seen various videos or we have seen it through our eyes, and it is just what earthquake is. It's in simple words, it is just shaking of Earth, and it's a natural event. So it is caused due to release of energy which generate waves that travel in all direction. For example, that this is Earth. From this point, energy is released. Now in one form energy is released in the form of waves. Now these waves travel all through the Earth's interior in different directions. We will be understanding more about the earthquake waves in later slides. So the release of energy occurs along a fault. Now what is a fault? For example, this rock and this rock. They used to be together earlier, but now they are broken. So this is called a fault. A fault is a sharp break in the crustal rocks. Rocks along a fault tend to move in the opposite direction, and the overlying rock strata press them. The friction locks them. However, their tendency to move apart at some point of time overcomes the friction. Now think that this is a rock, this is now broken, right? This is two parts of rock. It has this one rock lying over it. Now these two rocks want to move in different and in opposite directions, but this overlying rock puts force on them and do not allow them to move in different directions. So this causes friction, and when this friction is present, it leads to moving, or it leads to shaking of the earth. As a result, the blocks get deformed and eventually they slide past one another abruptly. This causes the release of energy, and energy travels in all directions. So when abruptly these move in different direction and friction occurs in a very large quantity, then energy is released, and that energy travels in all different directions. So the point from where energy is released, we'll better understand it from this picture, that the point from where this energy is basically released, this point. Can you see, like this point? This point is called hypocenter or a focus. So the point from where energy is released, so from this point energy is released, it is called hypocenter. And the point which is closest to on the surface where first this energy wave reaches is called epicenter. So what we called is hypocenter or focus, and this is epicenter. When these rock try to move into different directions and there is friction from the overlying rock, but still it manages to move or slide in different directions, that is when there is a fault line created and there is a release of energy. When this energy line waves travel in different directions, the nearest point on the surface where it reaches first is called an epicenter. So that is what we have to study now. So the point where the energy is released is called focus of an earthquake, and it is also called a hypocenter. We have seen that this is the hypocenter. The energy wave traveling in different directions reach the surface. The point on the surface nearest to the focus is called epicenter. It is the first one to experience the wave. It is a point directly above the focus. So it is the first point where the energy waves are first experienced. So what now we have understood about earthquake is that it is nothing but it's just the shaking of earth. Dharti ka hilna hi earthquake hai. And when there is a release of energy due to the shaking, that generate waves which travel in all the directions. Why the waves reach the surface? It is because there are certain faults present. Why are these faults created? Because the surface rocks want to move in different directions, but the overlying rock do not allow them. But when they manage to cross that level of friction, they move. That creates fault, and that leads to shaking of earth. Now the point from where this energy is released is called hypocenter or focus, and the nearest point of this focus on surface is called epicenter. It is also the first point which experience the earthquake waves. Now let's study the body waves and surface waves. So the earthquake waves, now when the waves are released from this point, they can be of two types, that is body waves and surface waves. Let's first understand in simple language that when these waves are inside the body of the earth interior, when these are present inside the interior, it is called body waves. When it reaches the surface of the earth, like when it reaches here, it is called surface waves. Simple, as the name suggests. So all the natural earthquakes take place in lithosphere. Now what is this lithosphere? It is in the coming slides. In lecture 2 of this chapter, we will study the various layers of Earth's interior. But for now, it is just important to understand that lithosphere is nothing but 200 kilometers of the surface of Earth. So for example, this is surface of Earth, this is 200 kilometers, this is lithosphere portion. An instrument called seismograph records the waves reaching the surface. Earthquake waves are basically of two types, that is body waves and surface waves. I've already told you that body wave is inside the Earth's surface and surface wave is when it reaches outside. So body waves are generated due to release of energy at focus and move in all directions traveling through the body of Earth. Hence the name body otherwise. The body waves interact with surface rocks and generate new set of waves called the surface wave. These waves move along the surface. When these body waves, so for example, these body wave is coming. Now there is this rock. There's this rock. Now connecting these rocks, a new kind of wave is generated which moves on the surface of the Earth. It is called a surface wave. And these surface wave move along the surface through the rocks. The velocity of waves changes as they travel through material with different densities. Denser the material, the higher is the velocity. Their direction also change as they reflect or refract when coming across materials with different density. Now, let's consider that this is a wave. It is traveling in solid. Now, in solid, the particles are more closer, hence the density is faster, hence the wave travel faster because density is more. Now, when it goes into solid, the molecules are spread a little apart. The speed of the wave decreases and also it may refract. Now, if it goes and if it comes back, it is called reflection. If it goes and it goes into some other direction, it is called refraction. So now we understood that there are two types of earthquake waves, that is body wave and surface wave. Let's see through this example that this is the focus from which energy is released. Till this energy waves are inside the Earth, it is called body waves. The moment it reaches and interact with the rock surface, it is called surface waves. Understood? I hope this point is clear. Now let's move to two types of body waves, that is P waves and S waves. Before understanding P waves and S waves, let's see what all we have to know about them. So we have to know their basic nature, how do they propagate, and what is their shadow zone. These all are the important things that we have to understand about P waves and S waves. Before initiating with this deeper, let's see a video. Alright, so now some things must be clear from the video, but let's go into further detail. Let's first understand what is P waves. So let me first tell you the full meaning of what is P here and what P stands for. It is called primary. Now what is the meaning of this primary? Primary always means first. First we have gone to primary school. So that is how the word primary. So primary waves are the waves which are first to arrive at the surface. But you must remember that these are two types of body waves, not surface wave. Means that they are only present inside the interior of Earth. They do not move and interact with the surface rocks. Now these are also called primary waves. The P waves are similar to that of sound waves. Now what is the nature of sound waves and how do they travel? We will look upon in this slide that how do they propagate. But let's first look into that. Do they travel in all the mediums? Like can they travel in solid, liquid and gases? So yes, P waves can travel in all the mediums, that is gaseous medium, liquid medium and solid medium. Now what point we have understood about P waves is that they are primary waves and they arrive first at the surface. They are also similar to sound waves. We look upon the propagation of these waves, and these can travel through all the mediums, that is gaseous, liquid and solid. The second type of body waves are called the S waves. S waves arrive at the surface with a certain type of lag. These are called secondary waves. An important fact about S wave is that they can only travel through solid material. This characteristic of S wave is quite important. It has helped scientists to understand the structure of the interior of Earth. So, the important point that we have to remember about S wave is that it is also called secondary waves, and point number 2 is that they can only travel through solid materials. They do not travel through liquid material or gaseous material. So now what we have understood, that the key difference between P wave and S wave is that P wave travel through all the mediums and S wave only travel through solid medium. So if there is any layer in the Earth's interior which is gaseous or liquid or not solid, then S wave will not be detected at that point of time. And it is also important to understand that seismograph will first identify P waves as their primary waves, and later S wave or secondary waves will be identified. Now let's read further that reflection causes waves to rebound, whereas refraction makes waves to move in different direction. The variation in the direction of wave are inferred with the help of their record on seismograph. The surface wave are last to report on seismograph. So first body waves are detected, then surface waves will be detected. These waves are most destructive. What waves are most destructive? That is the surface waves. So now we have already understood in previous slide that if wave goes and it comes back, it is called refraction. And if it goes and it strikes some material and then it moves into certain other direction, it is called refraction. This is the point that we have understood about P wave and S wave. Now let's see that how do they move. Alright, so different type of earthquake waves travel in different manners. Now, as they move or propagate, they cause vibration in the body of rocks through which they pass. So for example, now this is a rock. A wave is passing through it. It will cause a vibration in this rock. Now this vibration can either be like this, or this vibration can either be like this in the same direction as that of the wave. So this is the key difference between the propagation of S wave and P wave. So let's first try to understand it in the case of P wave. P wave vibrate parallel to the direction of wave. Now what does parallel mean? Parallel means these are the parallel lines. So wave moves in this direction through a rock. So for example, this is a rock. Now P wave moves in this direction. So the vibration will also be in this direction only. This exerts pressure on the material in direction of propagation. As a result, it creates density difference because somewhere the pressure exertion will be more, somewhere it will be less, which leads to stretching and squeezing of material. So let's see through this video, through this photo, that okay, so this is a rock. This is how the P wave is moving through this material. Now here more energy is being put by the P wave, so thus there is compression, there is stretching, and there are patterns of stretching and compression. As the P wave, the energy travels in the parallel direction to that of wave. However, now let's see what is the case of S wave. In the S wave, or for that matter all the other waves except that of P waves, the direction of vibration of S wave is perpendicular to the wave direction in vertical plane. So we have already known that okay, if this is the plane, this is perpendicular. So hence create trough and crest in the material through which they pass. Now we see that this is the rock through which S waves pass. Now it will create this troughs and crest. Why? Because the propagation is parallel. This is how it is moving. Troughs and crest, energy movement is parallel to that of vertical plane. So this is the the most important criteria about P waves and S wave, that P waves move parallel and they cause compression and stretching. However, S waves create troughs and crests, and because they move perpendicular to the vertical plane or perpendicular to the direction of S wave. Alright, this point is, I hope it's clear and it's also easy. So now let's try to understand the concept of shadow zone. We have already understood that P waves travel in all the medium, S wave travel in only one medium, that is solid. However, when they change their medium or when they move from one medium or medium A to medium B, there is some difference in the direction of wave, or there is some difference in the speed of the wave. So now let's imagine that, okay, now let's imagine this is P wave. It is moving from, this is solid and this is liquid. Now this is moving this. Now technically it should move like this, but due to the density difference in both the medium, it reflects here. So this part, it will have no P wave. What it will call? It will be called shadow zone of P wave. This is the simple concept of shadow zone. So let's try to understand that there exists some specific areas where waves are not reported. Such a zone is called a shadow zone. The study of different events reveal that for an earthquake, there exists an altogether different shadow zone. Now every earthquake in the world do not have same epicenter. The shadow zone will be relative to the epicenter of that, or the focus of that. We have understood that the point from where the energy is released is called hypocenter. So the P wave and S wave shadow zone will be depending upon the hypocenter of that wave. Now let's take for an example that this earthquake has this as a hypocenter. Now for example, this has this shadow zone. However, if this is the hypocenter, this will be the shadow zone. So each earthquake has their own shadow zone of P wave and S wave. However, the degree of that shadow zone, at what angle it will be, it remains same. So it was observed that seismograph located at distance between 105 degree from the epicenter recorded the arrival of both P wave and S wave. Let's look into the image of the shadow zone. That, okay, in this image we can see that this is what is called hypocenter. When we look into the 105 degrees in both the directions, we can locate both P waves and S waves. In this diagram also we can see that P waves and S waves both are coming in this direction. Let's read further. However, the seismograph located beyond 145 from epicenter recorded the arrival of P waves, but not that of S wave. So now when we see that, okay, when we look at to 145 and beyond it, we see only P waves. Do we see S wave here? So no S wave is recorded here. Thus a zone between 105 degree and 145 from the epicenter was identified as a shadow zone for both the types of waves. Now this is focus, this is focus. Till 105 extent, both P waves and S wave will be present. Till 145 from the epicenter, 145 degrees, no P wave, no S wave will be present. Beyond 145, only P waves will be present, S waves will not be present. This is the basic criteria of P wave and S wave. Now let's read further. The entire zone beyond 105 does not receive S wave. We have already seen that this zone do not receive S waves. The shadow zone of S wave is much larger than that of P wave, because P wave has shadow zone of 105 to 145, but S wave has 105 to 105 in both the directions. The shadow zone of P wave occurs as a band around the earth between 105 to 145. The shadow zone of S wave is not only larger, but it is over a 40% of Earth's surface. So 40% of Earth's surface do not have S wave, or seismographs there do not receive S waves from the epicenter 145 degrees. Alright, so we have already seen that now what is P wave shadow zone, what is S wave shadow zone, how do they propagate, what are their basic features. Now let's move further on the concept of what is the types of earthquake. So we have to understand that there are various types of earthquake, and earthquake can be due to various types. We have already understood that what is earthquake. Earthquake is nothing but it's just shaking of earth. So if we see that okay, there is shaking of earth or dharti hil rahi hai, that is basically earthquake. Now for example, if we put like a very heavy weight on a bed, the bed will also move, right? So if we put a heavy weight on the earth's rocks, underlying rocks will also move. So there can be various examples of how earthquake can be generated. Let's look into what can be the various causes. So the most common ones are tectonic earthquake. What are tectonic earthquake? Where the energy is released through fault lines. They are generated due to sliding of rocks along a fault plane. The whole concept of earthquake that we have understood, and that how it is generated, it is related to tectonic earthquake. We have only understood tectonic earthquake till now. We will now understand that what are the various other reasons for which earthquake can be generated. So special class of tectonic earthquake is called volcanic earthquake. However, these are confined to areas of active volcano. So now when there is active volcano and a huge amount of magma, dust particle, boulders, rock particles, gases, these all are released, and a large amount of energy is coming out of earth, it can also lead to some shaking of earth, and it is called volcanic earthquake. In the areas of intense mining, sometimes the roof of underground mines collapse, causing minor tremors. This is called a collapse earthquake. Now, for example, this is a mine. Alright, we are mining. The mine becomes so weak that the building, or what we can see, the underground mine roof itself collapse. Now when this huge portion of earth collapses, it is called a collapse earthquake because it causes minor tremors. The ground shaking may also be occurred due to the explosion of chemical or nuclear material. Such are called explosion earthquakes. So when there is a nuclear bomb testing or nuclear devices being exploded, there is a huge amount of energy which is released, and this huge amount of energy can lead to shaking of earth. This is what is called explosion earthquake. The earthquake that occur in the area of large reservoir. Now let's understand, this is very important to understand, that think that this is a surface. Now it is a large dam here. All the weight of dam is put upon these rocks. Now at one point it will come that rocks will not be able to hold the weight of this huge amount of water. Thus they will break. And this is why the dams can also lead to earthquakes. This is called reservoir induced earthquake. So now we have seen some example that why earthquakes can be present. These are basically tectonics, where energy is released to fault lines. Volcanic, due to volcanic activity. Collapse earthquake, when due to mining there is a collapse of underground rooftops. When due to explosion like chemical or nuclear explosion, and it can be also through reservoir, large reservoir areas being present, and it is called reservoir induced earthquake. Now there are two methods of measuring earthquake. Either we can see that okay, we have this device, it measures that at what rate the waves are coming, or what is the speed, or what is the intensity of these waves, right? When it calculates the energy from these waves, it is called a Richter scale. And when it sees the impact, that okay 6, we have already understood, or we have all seen on news that okay, 6 magnitude earthquake is there, 5.5, these all are Richter scale. it understand or it basically calculates the energy that is released. But if we say that okay, a 6 magnitude earthquake being coming in Japan or coming in Maldives, it has very different impact. It may not have any significant impact in Japan because they have their infrastructure being ready for earthquake, but it can have significant amount of impact on the Maldives, right? Because they are maybe not that ready for that earthquake. So the scale which measures the impact of that earthquake, that okay, how many people are dead, how many buildings fell, what is the loss of livelihood, all of these things, it is called a Mercalli scale. Right, let's study about these two scales. So the earthquake events are scaled either according to the magnitude, that is how much energy is released, or the intensity of shock, that is what is the impact or how much damage has been done by the earthquake. So the magnitude scale is known as the Richter scale. The magnitude release to the energy released during the earthquake, it relates to the energy which is released, and it is 10 to 0 to 10. However, the intensity scale is called the Mercalli scale. The intensity scale takes into account the visible damage. What is visible damage? How many people died? How many buildings fell? What is the economic loss? How many animals died? And it is present in the range of 1 to 12. So we have seen that there are two methods of measuring earthquake. That is basically Richter scale, which measures the energy released, and then there is a Mercalli scale which measures the visible damage which is caused by the earthquake. The last portion that we are going to study in today's video is basically what can be the effect of earthquake. Okay, so think now in your example that in your area an earthquake has come. What all can you see? Like a major earthquake has come. What all can you see? You can see the ground shaking. That is what earthquake is. You can see differential ground settlement. For example, there is this plain area. Now suddenly earthquake comes. In this part, it goes down. Now there is, because it goes down, earlier it was on an equal level. Now there is ground differentiation. It is up, it has gone down. So the earthquake can lead to ground differentiation also. It can lead to land and mudslides, because earthquake can cause tremors or it can cause ground shaking. The land can loosen up and it can flow. It can cause soil liquefaction. When soil and water are added up, then it causes soil liquefaction, right? Then it flows. Sand also flows with water. It can cause ground lurching. Ground lurching is what? That is movement of ground. It can cause avalanches. Avalanches is what? It is of the ice. When ice moves, like landslide, ice when moves instead of the soil or land, it is called avalanches. It can cause ground displacement. It can cause floods from dam and levee failures. Now, because when there is, we have already seen that there can be a reservoir induced earthquake. So for example, think that now there cannot be more pressure of water in the dam. Now dam breaks and the water comes down. There can be flood, right? There can be fires because the electricity cables can be disturbed during the earthquake. There can be structural collapse because infrastructure can be collapsed. Buildings can collapse. In India also buildings are not much earthquake resilient till now. Falling objects can be present and tsunami can also be present. Tsunami we'll be dealing in much detail in the oceanography chapter. But now just imagine that okay, this is ocean. And in ocean there's this earthquake comes. Waves are generated. Now from these waves, tsunami comes. Alright. So tsunami is not a direct impact of earthquake. It is an impact of the waves which is generated through the earthquake. So we have seen this chapter and we have dealt the first part of this chapter, that is still the earthquake portion we have dealt. In tomorrow's lecture, we will be dealing with the portion that is left and we will be completing this chapter with volcanoes being the last part. So I hope you like this video, and it is very important to visualize in geography. For that purpose, we have added various like AI videos, and I've also added like the NCERT examples and various other examples I've also added in the form of images. So do pay attention to these images and try to recognize and remember them, and also make them in your example in mains. I hope this content was useful for you. So for such more informative videos, don't forget to subscribe to UPSC with AS and do like this video and do share if you like the video. We'll be coming up with more such informative content. Thank you. That's it for now. I hope you have a good day. Thank you.